continuing with 1.4 and 1.5, Geometry Geniuses. 1.5 in particular talks about the different kinds of angle pairs that we come across. This can help us identify geometric relationships and also help us find angle measurements. So we come across 4 of these, the first one being adjacent, which these are 2 coplanar angles with a common side, common vertex, and no common interior points. The examples given here say that angle 1 and angle 2 are adjacent to each other, so adjacent angles, also adjacent angle 3 and angle 4. So you could think of this as like a neighbor that you share a fence with. So if your house is here, you got a little roof, and it looks like an Adidas. Yeah, it almost looked like the Adidas logo for a second. So if you have all of this space for your house, and let's say that your neighbor has, I don't know, let's call it just a shack. Or no, they have a tree house. That's pretty sick. You would say that your house is adjacent to the tree house because you share space, you share a wall, or you share this fence, but you don't have the same land per se. So you would say that your house is adjacent to the tree. You share the fence, but you don't share the same land. Whereas for vertical angles, we have 2 angles whose sides are opposite rays. So in this case, it's as if all of these houses or these angles meet at one point, creating 4 angles. We would say that angle 1 and angle 4 are vertical because they're kind of right on top of each other, even though this looks sideways. There you go, now they're top down. But you could also say the same thing for 2 to 3. So you could say that angle 1 and angle 4 are vertical, along with angle 2 and angle trace. Those are fair game things to say. So adjacent, you're right next to each other. Vertical, like think of it, skateboarding, a vert ramp goes up and down. So up and down, those are vertical angles, if you can kind of stack them one on top of each other. Complementary angles, oh, I love complements. Also love right angles. So complementary angles really just add up to 90 degrees. We could say that angle A and angle B, if angle A is 47, angle B is 43, those together are complementary because they add up to 90. Whereas supplementary, what's up, what's goody, that's a complete 180 for me to say something like that. But those add up to 180, just 2 angles that add up to 180. Cool. So we have this diagram here. We'll give some examples of adjacent, vertical, complementary, supplementary, all the good ones. And I'll give you some refreshers along the way. So name a pair of adjacent angles. Well, we know that the adjacent angles from before kind of shared a fence. So we're looking for angles that are butt up next to each other. So I know that AFB, and there are lots of answers you could put for this. So AFB, we could say that that is adjacent to BFC. Because they share the same line, F to B. That's fair game. For adjacent angles, this is a little tricky for vertical angles, this is tricky because they have to be right on top of each other and they have to look similar. So that's important. If we look around, can't see a ton. One that definitely jumps out at me is that this EFD from here to here kind of looks like the sum of AFC. And if we were not too sure, we could add up our angles. So 90 and 28 equals that 118. So that's actually fair game. We can say that those are vertical. Complements. I love complements. So let's complement and find the 90-degree angle. That's a pretty easy spot. Well, is it? Let's find out. Complementary angles, we need two of them. They need to add up to 90 degrees. Well, 90 is already spoken for, so 90 and 62 won't work. 118 is not going to work. Let's see. BFC is not quite 90 degrees. And is there another angle that would definitely get us to the 90-degree mark? CFD could work. And I know CFD is going to work. Although there's no angle written here, we know that this full circle is going to have to be 360. And if all of these are spoken for, then this has to be the leftover portion, because this is a straight line, this is 90, this is 28, so that would have to be 62. So CFD is 62. And although it wasn't written, we can assume this because of the visual. Supplementary, what's good? What's up? We can get 180 degrees if we took the 90 degrees from AFB and we added on 90 more, which would be BFT. And notice we can do BFD because it's 28 and 62. 28 and 62 gets you 90. That gets us 180 altogether. Ooh, making me think about this, or making me think about this. Are AFB and EFD vertical angles? Well, let's find AFB first. AFB is that 90 degrees. AFB, EFD. E's a little bit more out here. D's down here. Although AFB and EFD share the same vertex, what do you think? Are they vertical angles? Do they have the same measurement? No, they're kind of off, so no. But as far as adjacent angles, are they? Well, no, that's not going to work either because they don't share a ray butting up against each other. So that's also no. So here you saw the four types of angle pairs: adjacent, right next to each other, vertical, up and down on top of each other, complementary, I love complements, which provide 90 degrees based off of two angles. Supplementary adds up to 180, and it would be two angles. So recall that these are only pairs, so you only want two angles to make these up. I don't have three or so. These will be used again and again as we move throughout the year. So angle pairs. Thanks for watching.